Glad to meet all of you all virtually here. So just an agenda, I want to go through some personal education experience, a little bit about Equitrans Midstream, who I work for, what we do. STEM at Equitrans Midstream, I took a little different approach than Val, and I do have a lot of, some info on engineering, but also some info on some technical stuff, some science that maybe you don't have to have an engineering degree for. And then some focus area for student development. A lot of what Val's already hit on, honestly. Okay, so personally, I went to Ripley High School in Ripley, West Virginia. I think maybe some of you on here are from West Virginia. I then went to West Virginia Institute of Technology in Montgomery, West Virginia, and received a Bachelor of Science in Electrical Engineering in 1994. And then went on to University of Texas at Dallas in Richardson, just outside of Dallas, Texas, and got my MBA in 2000. So from a work standpoint, I spent a little over 21 years in design engineering and management and telecommunications. So I originally went to work right out of college in 1994 as a field engineer for MCI WorldCom. A lot of you on here probably never even heard of that. But I started as a field engineer, then became a design engineer, got promoted into management, and then on up through management. And as you can see, I worked there for about 9 or 10 years. Very good company. I then decided to move back to West Virginia. I spent some time in Chicago with MCI WorldCom. Then I spent 7 years in Dallas, Texas with MCI WorldCom. Decided to move back to West Virginia, went to work for Verizon, who was later purchased by Frontier Communications, and worked there from 2003 to 2015. Started out as a director of engineering, got promoted to vice president. When I left there, I was the vice president of engineering and construction for the Eastern U.S. Since then, I moved to Pittsburgh, Pennsylvania in 2015. So I've spent 7 years in engineering management in the natural gas industry. I've worked for EQT, which is now Equitrans Midstream, for that entire time. So basically for 28 years, I've had a STEM-focused career. You know, what really drove me into STEM, into engineering in particular, was just curiosity. You know, when I was a kid, my dad used to always tell me, Jason, everything you do, you want to try to, you know, anything toy you get, you take it apart and try to put it back together every time. So I just always had that curiosity, and really not knowing much about what engineering was. You know, you all have people have a great opportunity now to listen to things like this and Google stuff on the internet. You know, when I was in high school, there was no internet, no public internet. People didn't have the internet. So, you know, we would go to career fairs, you'd talk to your guidance counselor, but it was all, you know, looking in libraries, talking to people. And I didn't have a really good feel for what an engineer was, but I thought that's what I wanted to do because I was really curious and interested in how do things work? How do you make things work? How do you make things better? So it turned out really well for me. I've had a great career in engineering. I love it. So a little bit about Equitrans Midstream, a lot of colored lines over there, and I'll go through a little bit of this, but we are headquartered in Canonsburg, Pennsylvania, which is just south of downtown Pittsburgh. We're a 135-year-old company. We focus on sustainability. You know, it's a big thing in the world today with emissions and stuff like that. We have a large focus on methane reduction, emission reductions, carbon neutral, you know, things like that. We have 750 plus employees. We have 1,900 plus miles of gathering pipeline. We have 750 miles of regulated transmission pipeline, and I can go into a little bit about what that means in a second. We have 580,000 horsepower of compression where we compress natural gas. And on a daily basis, we transport 8.2 billion cubic feet of natural gas. We also have 180 plus miles of water pipelines. And basically what those water lines do, you probably are thinking, why in the world do you need a water line in the gas industry? We provide water to the wells that they utilize to drill the wells with. So basically in the natural gas industry, there are three kind of divisions of it. There's what's called the upstream, the midstream, and the downstream. So the upstream are the wells, the gas wells that are drilled. My company doesn't have anything to do with that. The midstream is what we do. So we build pipelines and compressor stations, and we interconnect with the production companies that drill the wells, and then we transport the gas from the well pad to the downstream companies. The downstream companies are people like, in this area, People's Natural Gas, Dominion Gas, Mountaineer Gas. For you all out in California, People's Gas and Electric. Basically, that's the natural gas line going to your house. So we call that the distribution company. They distribute the gas to the end user, which are either businesses or houses. And then I can't go on without saying safety above all else, and a commitment to responsible operations that protect our employees, our contractors, and our communities. That is our one of our core values in our company is the safety and the protection of all of our assets, all of our people, all of our customers, anyone we interact with. So that's a little bit. If you look over here on the right on the screen here, you can see all these different colors. I just cut and pasted this out of one of our brochure kind of things, but you can see our interconnected pipelines and what we have. We don't have a very large footprint. You can see that Pittsburgh, Pennsylvania is right here in this mess right here. Actually, it's a little north of here. It's up here. But, we're basically in southwestern Pennsylvania, northern West Virginia, and then a little bit over here in eastern Ohio. With only 750 employees that we have, I didn't put this on here, but we're the third largest natural gas transportation company in the United States. So what does STEM mean to us? Like, what do we do? How do we apply STEM? So like I said at the beginning, I want to talk a little bit about the non-engineering piece of STEM. The science, the technology. So, we have, I listed a few out here. We have operators that work on our equipment, work on our pipelines. And what do? They maintain our assets so that they safely operate. They're very hands-on, mechanical. The majority of their time is out in the field. So I've got a picture right here. This is a compressor station where we compress the gas and move it on down the pipeline. This right here is a 5,000 horsepower Caterpillar engine right here, driving a centrifugal compressor. You can see it has these ends on here. There's 3 on each side. It's called a 6-throw compressor. And basically what we do is the gas comes into this station, and basically it's at a certain pressure. And to transport it, to move it on, you compress that gas to increase the pressure, which increases the flow. So, a prime example of what we would do here is we would have gas coming into this compressor at 300 pounds per square inch, or PSI. We would compress it up to 1,200 pounds per square inch, and then move it on down the line to the next compressor station. And in between, we may have interconnects with some of the distribution companies where we're selling them gas that then goes to your house, your business, etc. Run your furnace, your cook stove, so on. Technicians, that's another title that we have. Again, they maintain our assets that safely operate. They do a lot of troubleshooting, right? If gas isn't moving right, if we're seeing errors in our control room and it looks like we may have a valve that's stuck, a technician will go out there, troubleshoot, work on that valve. They develop set points, right, to look at pressures and flow rates throughout our entire network. The engineer will design what that equipment would be and what the set points should do, but the technicians will go out there and actually set those set points and say, without getting too technical, then you won't know what I'm talking about, but like a pipeline, for example, the pipeline's rated for so much pressure. Say it's rated for 1,400 pounds. If we would have a valve stick open and we would go to overpressure that pipe, as it reaches that 1,400-pound set point, we have relief valves on that pipe. So it won't allow the pipe to overpressure. It'll relieve gas to atmosphere and alert us. So our technicians would go out and set all those set points. The operators would go and troubleshoot if there's a problem. And then lastly, in the office setting, we have our IT group, right? We have a very vast control room, very complex control room that monitors our assets across the footprint, looking at flow rates, looking at design points, looking at pressures. And our IT group kind of oversees all that. And then obviously engineering. So just a little focus on the engineering to break out the E in STEM I've highlighted here. Again, like Val said, you would think, Val would probably think with her background in mechanical engineering, oh, the majority of these engineers are mechanical engineers. Not true. Just like she told you, every engineering discipline we utilize. So mechanical isn't obvious, I agree. They do pump designs, motor designs, valve designs, the pipeline design. You know, they run calculations and determine based on, you know, our customer needs X number of cubic feet delivered to an endpoint. A pipeline engineer who's typically a mechanical engineer will determine what size pipe do I need to transport that much gas at that pressure. What does the wall thickness of that pipe need to be so that it can safely operate? Where do I need relief valves that I talked about earlier? Things like that. Electrical engineers, we have a lot of electrical engineers, I'm one of them, but they do the power design. So you think about that compressor station I showed you a picture of, there's a lot of electrical power required for that. So our electrical engineers design all of our power for all of our sites. They design the communications, right? I told you all I spent 21 years in telecommunications. That was it's still applicable to what I do today. You know, we have to have connectivity, fiber optic connectivity between all of our sites so we can monitor and watch and, you know, all the gas flow. Automation and control. That is a very interesting field, in my opinion. If I had to do over with, I probably would go into automation and control, to be honest with you. So what that involves is controlling a system. Like, well, take a compressor station, for example. They will come up with the documentation and the design that says, you know, at this set point, at this pressure, open this valve. If you pressure drops below this point, then automatically close this valve. They do all the design of that. Very interesting stuff. Chemical engineers, they do process design. Val did an outstanding job at explaining process design, but within the natural gas industry, we have a lot of processes that they design. They do liquids modeling. Natural gas there's a lot of temperature dependencies to it. And some of the basic math around natural gas is as you cut pressure, the temperature cuts with that. So for every 100 pounds of pressure drop you have, you lose 7 degrees Fahrenheit in temperature. So as you can see, as you can imagine, you know, if we've got a location like, let me back up a step. The gas coming to your house is under 100 pounds, 100 PSI, pounds per square inch. Because the piping within your house, the plastic, that's all that can withstand. Your stove in your house, that's what it requires, is a lower pressure gas. So we're transporting this gas at high pressure so that we can move it along for greater distances. And then when we get to a point where we go to a distribution company where we're cutting the pressure, you can imagine, say if I cut from 1,400 pounds to 100 pounds, that's 1,300 pounds times 7 degrees Fahrenheit per pound, whatever that math is, 80 some pounds, right? 80 some degrees you're dropping. So if you start out with 50-degree Fahrenheit gas, now all of a sudden you have negative 30-degree Fahrenheit gas. Any water that's in that gas, which natural gas naturally has water in it out of the ground, can freeze. So our chemical engineers, they determine where do we need to add heat? Where do we need to add line heaters to heat the gas so that we don't have freeze-offs? And then finally, civil engineers. As we're building pipelines, especially in this part of Appalachia, there's a lot of hills up and down, rugged terrain. Our civil engineers, they look at landslide remediation. They proactively try to, as we're building pipelines, they will proactively talk with our construction team on, here's what you need to do with the soil so you don't have landslides. They'll design all of our site plan, our site development, right? If we're building a compressor station, then they'll lay out all of the earthwork design, what the cut fill is on the site, where the heavy equipment operators, what they need to grade the slope to. And then also erosion and settlement control plans. So as we're building pipelines, we've got to make sure that any water runoff, because we've eliminated some trees, we've got to make sure any water runoff doesn't cause flooding, doesn't get into local streams, etc. So they'll design those erosion and settlement control plans. All right, so some of the STEM ideas for teachers, continue focusing on math. Telecom and natural gas have math as a basis. Encourage students to take advanced math and science courses, especially ones that want to go into a STEM career. That is the basis for engineering. Another idea I had, and I'm sure a lot of the teachers are doing this, but partner with companies like Equitrans Midstream and like Procter & Gamble, different STEM industries, for mentorships, real world projects. If we had a class that wanted to look at a compressor station design, we would work on that with you, quite honestly. And even potentially some funding. We partner with a lot of education facilities or county educations in West Virginia, different county and local school districts in Pennsylvania, in Ohio. We partner with them and help them financially with some funding. And then the last thing I have on here is the same thing that Val said. Critical thinking and collaboration are key. Engineering is not all about math and science, which I say at the top here, it is. But to be a successful engineer, you've got to have critical thinking. You've got to be able to collaborate. You can't just be what I would call book smart, right? There's a lot more to being a successful engineer than just knowing calculus 3 and differential equations and all these advanced courses. To be successful, you've got to really be good at critical thinking, collaboration, problem solving, so on. That's all the slides I have, but I do have one show and tell that I wanted to show you all. This is, and I'm going to hold it up here, I'm hoping it works. Would anybody have a clue what I'm holding up right now? All right, so what this is a cutout of a piece of high-density polyethylene pipe, HDPE pipe. So we've recently had some failures on some pipes. So this is a really good thing about what engineers do, right? So we have been working and trying to determine why is our pipe failing. So I took this pipe to a lab last week, ran some tests on it, and I'll show you what we did. So it's hard to imagine, but the pipe, this was cut out of a circular piece of 18-inch pipe. And what we did was, I'm going to put my finger in. When you have HDPE pipe, you fuse it together. Instead of welding like you'd weld a steel pipe, you melt and fuse this plastic pipe together. So what this is right here where my finger is, this is the fuse right here. And The rest of it was just a chunk like this right here, all the way across. And what we did was we put this piece into it's called a tensile test. We put this piece in there like this through these two holes. We drilled these two holes in it, put it in the machine, and we pulled it apart. So it basically, this is going to prove whether our craftsmanship on making fuses is good or not. If our fuse was not good, this would have popped in two right here. If the fuse is good, the fuse should be stronger than the base material, which is the HDPE pipe. And as we apply pressure and pull it apart, it should just stretch this like Laffy Taffy or like Play-Doh. And sure enough, as you can see right here, it stretched the material. It was almost to the point of breaking and we stopped. You can see a hole in it. But what we proved there was our problem with our recent failures we've had is not our fusing techniques, which a lot of people thought was the problem. We proved that our fuse is accurate. Now, what is our problem? We're still looking into it. I don't have the answer. You have to come back next time. But what we did prove was we disproved the fact that a lot of people thought it was our fusing and our human, technicians out there doing the fusing. It wasn't. The fuse was perfect. All right. Any questions now?
Yeah, we do have some questions. And actually, let me see if I can get a different view here. All right, that's better. So yeah, actually, and I'll be honest with you, some of these other questions that we had earlier are great questions. So let's start with real quick. What was your favorite subject in high school?
Again, it would be math. That was my favorite thing, and I enjoyed it the most, and I did the best in it. So, math was my favorite subject.
What do you like most about being an engineer?
I think solving problems. That's the best thing, and you get to see an end result, right? A problem is presented to you, then you take the necessary steps, whether they be simple, complex, short, long, whatever, and then in the end, you solve that problem. That's probably the best thing about being an engineer, in my opinion.
Well, I guess, because I think this is kind of interesting, we're on a math trend today. So what's the hardest math you do at your job?
Probably like same thing as Val said, probably algebra and geometry, quite honestly. Now, there are some more advanced things in the design of pipelines that takes calculus into account, but we don't have to do it by hand. We buy software that does it for us. So, right, we put the parameters in of we want to move this much gas at this pressure. It runs it all in the background and it comes back and tells us the result. And there is calculus and a lot of advanced math in it, but my engineers don't do that by hand.
Awesome. No, I think it's really encouraging for students to realize that, like, and I think some of it is like the calculus helps you think about like how the math is related to itself in some ways. Because I always thought that was really interesting with calculus, and gets you to think a little bit. But
Yep.
you're not like sitting there solving calculus problems all the time. And I guess, what does a day in your life at work look like?
So a day in my life, it's a little different in that I manage people. So the majority of my time I'm in meetings. So I spend a long time looking at budgets, right? Where are we at on this project? Doing readouts of, the budget was this. We're 90% complete of the work, but we're 95% of the budget spent, analyzing that, et cetera. But I'll answer maybe more of the engineers that work for me, a day in their life. They are assigned projects, whether it be pipeline, compressor station, or whatever. And basically they take the inputs, the required scope of the project, what does the customer need, and then they design a solution, whether it be the size of the pipe, the length of the pipe, the pressure of the pipe. They design a solution that meets the customer's needs. And it's a lot of detailed design, detailed engineering analysis is what they do. It's definitely an engineer job.
Yeah. So then I guess a different question though, in terms of your career, is how has your engineering background prepared you kind of to take on some of this management stuff that you're doing?
Great question. So I think there's two things. One, I started off as a field engineer, and I tell people this, I've been telling people this for 28 years. A fresh engineer out of college, I think the best thing they can do is get a hands-on job, whether it be in manufacturing, whether it be in telecom, whatever industry it is. I spent my first about 2 years as a field engineer, and I really got to the ability or the understanding of the technical aspects of how things work. And then when I went to the office and into an office setting as a design engineer, I had that technical fundamental background of how it worked. And that led me to be kind of a top candidate for management if I wanted to go that route, because I had that firm understanding. And then the other thing I did, if you remember on my experience there, I did go get an MBA pretty quickly out of college, well, within 5 years out of college. And that helped me also in the management.
Awesome. That's actually a really interesting answer. I had someone else who kind of talked us through the different stages of an engineering career, because he had just started the middle of his career and kind of getting into some management. And it was just really interesting to hear how that kind of transitions and transforms. Yep. And my last question, because I think this is always a good one, is what's your best advice for students who might be interested in engineering or natural gas?
I think, continue to take technical classes in high school. And then I really like Val's answer, right? In that, get involved in other things. Don't just study in books, right? Do some hands-on things. Get involved. My son, for example, he is a junior mechanical engineering student at the University of Tennessee in Knoxville. But when he was in high school, he was in the STEM program in high school and did robotics. He did all these different things, and it really, really broadened his horizon and his knowledge base. So I would recommend just, obviously continue studying hard, really focus on the math, the advanced math, advanced science classes, but don't just do the book work, right? Get involved and learn other things too. It'll really help you.
Awesome. And that is all the time we have. I want to thank you so much for presenting tonight.